Today we will deploy an acoustic backscatter profiler in the Rhône River. So this is the acoustic backscatter profiler, AQUASCAT 1000R. These are the transducers. They will send sound into the water and record the backscatter echo. We have various transducers at various frequencies. The lowest one is 300 kilohertz, and our highest frequency is 5 megahertz. So first step is checking whether the instrument can communicate with the laptop. So we plug this cable to the instrument and plug the other side of the cable, which is a USB connector, to the computer. Then we open AquaTalk, that is the software provided with the instrument, and click on Connect, just to check if the logger information appears that indicates the instrument communicates with the laptop. Second check is to plug one transducer. There are 4 channels. Channel 1 is marked with a purple point. Then channel 2, 3, 4 are located clockwise. We click on Deploy to check whether the instrument is actually working. As we just plugged one transducer, we select the corresponding channel and the corresponding frequency and set the other channels to non-selected. Then click on Next.
The logger time, next, just until next. Okay.
The setup is done and we start at 11 past 10. When the instrument starts to record, we click on real-time display and check whether we can see some signal. This check is important prior to the deployment to be sure that everything works well. Most usual issues include low battery and communication with the instruments, most often because of broken cable or laptop driver issues. Now we fix the transducer on the boat on a custom stand. We put some pipe insulation foam on the back of the 300 and 500 kHz transducers because we observed some backward reflections at these frequencies. It means the transducer is sending a signal in the forward direction but also in the backward direction. This can be due to problems in transducer backing. In our case, as the transducers will be down-looking, it means we will get an echo from the water surface. So we put some insulation foam to reduce these interferences.
This is the first channel.
We are ready for the deployment. The transducers are dropped into the water, down looking, and it is important to record the depth of the transducers from the water surface for further analysis, for instance to detect interferences from the surface. AQUASCAT files are identified by their recording time, and sometimes it can be useful to have a clock synchronized with the instrument and with the laptop to help managing the field deployment. Now everything is ready, we start recording with the AQUASCAT. We click on Deploy and select the transducer frequencies and their corresponding channel. Then click on Next. One can give a name to the logger regime, check the logger time, and we have no auxiliary instruments. Given we have small particles in suspension in the river, we expect the backscatter to be very weak. Thus, we will amplify the signal as much as possible with no risk of saturation. We set the bin settings so to record the profile down to the bottom of the river, and very importantly, before recording the backscatter, we record a noise profile by setting the transmit power to off with the exact same settings of bin size and gain at reception. Here profiles per average is set to 1 to be able to check for the signal statistics in further analysis. Now the AQUASCAT will record the background noise. When the noise is recorded, we'll record the backscatter by setting the transmit power to full. When the instrument is actually recording, we click on real-time display to check the signal. For the two lowest frequencies, we see a peak which is the bottom reflection. On the contrary, the two highest frequencies fall down to the background noise level after a few meters because of too high attenuation. By clicking on ABS scrolling, we see the time series of the signal. We can clearly see the bottom of the river, check for signal steadiness and potential interferences, as we can see here at 5 MHz, very strange small interferences.